Hey guys, hope everyone's doing well and welcome to my channel Math Coder. In this video, we will see how to solve the C question of Codeforces Global Round 14. After a long time I did the C question, so I thought of making this video. So basically in this question, we will be given n blocks which may be of different sizes or same size, and then we have to construct these many m towers such that the size of the towers should not differ by more than this k value. So the first thing that strikes our mind is what we can do is we can sort the array or the vector. So we'll get something like this. Now if you see the m value for this was given as 2, so we had to construct two towers, and then the maximum size difference should be 3 in this case. Am I right? So after sorting, what we can do is we can basically insert the largest two elements in these two places, like 2 and 3. Actually, the reason for inserting the largest two numbers, or in order to decrease the differences, like say we have only 1, 2 and 3, and then m value was given as something like 2. So what we can do is we can basically construct like this. But if we put the greater two elements in the same place, like 2 and 3, so it will become 5. And then if we insert the first element over here, then this would be the possible value that we will get. Now if the difference value was given as something like 3 or lesser than 4, then this case will not pass, right? Because the difference of the heights will be 4, but it should be lesser than this k. So in order to decrease the difference or reduce the heights that we have, what we should do is we should insert the biggest two elements in our vector or in the set. So if we insert 2 and 3 over here, then the difference of this initially will be only 1. And inserting this first element or the remaining elements, we should think of inserting in some place which will reduce the difference or not increase the difference further. I will explain this one with the first example itself. So after inserting the largest two elements, these two things will be eliminated because the m value is 2, so we are creating two places. For this I'm using a set. I will tell you why I'm using it and not a vector or something. Now while inserting this the subsequent elements, I should think of inserting it someplace where the difference would not be increased further. If I insert it in this place, then it would become 5, and then the difference would be 3. But if I insert this 2 in this place, this will become 4, and then difference will be 1. So the difference 1 is lesser than the difference 3, which we got by inserting it in this place. So if we insert the remaining elements in the biggest place or the largest place, then the difference would be increased. Like in this case, it will become 5, and then the difference would be 3. So the difference would increase if we insert it at the largest place. But if we insert the remaining elements in the smallest place or the least index, then the difference of the first and then the last elements or the heights will remain something smaller than the previous one. So let's see what happens if we insert this 2 to the least possible value or the least possible index. So after adding this 2 to this 2, then it would become 3 and then 4, right? So this will become 4. So the difference is 1, which is lesser than our required value. So now after this, I would sort it. Actually, I would not explicitly sort it, because as I'm using sets, it will implicitly sort my elements. So after this process, this would become 3 and then 4. Now 3 will be our least value, and then 4 will be our greater value. And mind that the elements need not be only 2 or 3. M can be something like m can take a value up to 10 to the power 5. So what we have to do is we have to just check, just insert it at the initial place. And then after inserting all the elements, we have to check the difference of first and then last element. I will tell you why. So if we insert this one, this will be eliminated, and we will have two other elements. And then if I insert it in this place, that is in the 3, then this would become 4. And then so after this I would get 4 and 4, so which would be 4 and 4. And then the remaining element will be only 1. So I will insert it in the first place, which would become 5 and then 4. After sorting, it will become 4 and then 5. Right. 4 and then 5. Now, after inserting all the elements in the m places or the n towers, what I have to do is I have to check the difference of the first element and then the last element. In this case, it is only 2 elements, so it's not a big deal. But let's say we have something like this, and then the first element is 2, and then the last element is something like 8. And then the restricted value that we have for k is something like let's say 6 or 8. Okay, sorry. Let it be like 4. So if I take the difference of these two heights or these two towers, then it would be 6. As the 6 is already greater than this 4, my answer should be no, because there is no such possible arrangement which would suffice our condition. So we have to print no in this case. But if it is something like more than 6, like 6, then this case would pass. So as I'm using a set, the elements would always be in the sorted order. So let's say the elements is or something like 2, 3, 5, and 8. So I need not check the difference of this one and then the greatest element or any other element, because if I check the first element and the last element, so the difference would be the highest possible value, right? 2, 1, 8 will produce 6 as their difference, and then if you take the difference of any other element, it will be just lesser than this 6 value. So if I take the difference of the first element, that is the least element, and then the largest element, then it is enough. And then we have to check whether that difference is lesser than or equal to our k value. So this is the logic that I followed during the contest, and yeah, it got accepted during the contest. So what I felt was it was much of an implementation question rather than a logic. But after the contest, I realized that there was some simpler logic than this. That is, we need not sort the elements in the first place itself. First, I will show my accepted code. Actually, my implementation was much vague. I will tell you one simpler implementation afterwards. So what I did was I created one vector which had 2 pairs. There is pair for containing the element, and then another pair which will have the initial position and then the tower number. Like initial position will be the number where the elements were inserted in the first place, and then this is for the tower number at which position this should be inserted. So I will tell you what I did. So before sorting, it was something like let's take the first case. So it was 1 2 3 1 2, right? 1 2 3 1 2. So the initial positions is 1 2 3 4, right? And then this will be blank. So it will have 2 values. First value is the number, and then the second value is the tower number, which is not reserved now, and then third value is the initial position. So there will be some value which has to be inserted over here afterwards. This is the tower number, and then this is the initial number, and then this is these are the initial values. So after this, what I did was I sorted the elements in the reverse order. So this is ITR, which is one macro for getting the reverse, getting it from n to begin. So as I'm sorting it in the reverse order, so it will be something like 3, 2, 2, and 1 and 1. The advantages, the initial positions will still remain the same. It will be 2, 1, 4, 0, and 3. Yeah, something of this kind. So after this, I am inserting the first two greater elements in one set. So I will create a set which will contain the element, that is a sum element, and then this is the position of the tower. So I would do this. This is nothing but inserting the greater elements along with the tower number, like this. So this is like 2. So this is 3, which is the largest number. This will be 3, and then the tower number will be 2 for this. So this is 2, and then the tower number will be 1. So I'm doing m minus 1, which will give the tower number in the reverse order. So it will be 2 and then 1. After this, these two elements are inserted. So I will go with these two things. But there is a column which is still remaining over here, right? This is for the tower number. So here, if you see, what I'm doing is I'm inserting the m minus 1, that is this value, in this corresponding positions. So this is the tower number 2, and then this will also be replaced with 2, and then this will be replaced by 1. So it indicates the tower which these blocks should go. So I will insert this 2 in the least position, which is 1, which is this 1 position, and yeah, this will be done in this loop. So what I'm doing is I'm looping it from m value to the end of the vector. I will take the iterator for the beginning position, or the first position, and then I'm storing that position, that is the tower number, in the corresponding vector's location. That is in this location I will store this value. So I will store this m because it should go to the least value. And after this, what I'm doing is I'm creating one variable called sum, which will contain the sum of the element. The sum of this initial value plus this value. So this value is 2, and then the initial value which was it contained was 2. So sum will have this 2 plus this 2. So it will be sum will be 4. And then I'm basically erasing the value, that is erasing this 2 value, and then replacing it with the sum. So it will become 4, 1. The thing that you should take care is this s.begin always returns a constant iterator. That is, you cannot modify the previously present value. What I thought of doing was just doing it. It is the iterator for the first value. So what I thought was it of first equals plus or plus equals this is 2. But the thing is, this will produce one error, because this it.fs, it will return a constant iterator. As this is a constant object, it is a read-only object, so you cannot modify the value which is already present. So what we have to do is, you have to take the sum in a separate variable like this, and then erase the previously present value, and then insert the modified sum, and then the tower location, which is stored in this location. So this will be the our present. Okay. So after this, we have to insert these two elements. So one should be inserted in this position. So I will modify this this array value, is the tower number, to 2, because it should be inserted in this 2, and then I will replace it by its sum, which is 4, because 1 plus 3 is 4. So this would become 4, and then I will be left with this 1 alone. So this 1 should be inserted in this 2th location. So I will modify this to 2, and then this will be replaced by its a sum, which is 5. So as I'm using set, it will be automatically sorted, and the final configuration of a set will be something like this. And then the thing that I have to check after this is whether the value that is present at the first location and then value as the last location, or of a difference which is lesser than the k. So 5 minus 4 will be 1. So after exiting from the loop, what I'm doing is I'm checking the difference of the first and then last element alone. So for the last element, in order to access the last element, what I'm doing is I'm taking the iterator of that and then decrementing it by 1 so that it will point to the last element, and then I'm just checking the difference of those two values and checking whether that is greater than this k. So if that is greater than k, then I will print no. This is one macro for that pp. pp will just print whatever we give, like this. So this is the definition for pp macro. So I'm just printing that n value because the difference should not be greater than this k, right? Else what I would do is I'll print s in the first place, and then I will create another vector which goes by the name res. And then what I'm doing here is this these are the initial positions, right? So I will insert this 2 value in this corresponding position. There is v of I dot ss of ss will mean this value. There is if it is 2, then I will go to the second index of this res vector, and then I will place this 2 over there. So this is what I'm basically doing, and then I will print this res array, just printing this res vector. So this fe is also one macro. This is just for printing the vector. It is present somewhere here, yeah. See, so what I'm doing is I'm just taking the I'm accessing it by range based for loop, and then I would just print those values. That's all. So this is one implementation. But the thing that I noticed after the contest was we need not sort the array in the first place. I'm sorting here, right? As we are using a set will automatically do the sorting for us. So what we just had to do is we have to insert the elements in the same order as it is given. Like let's say it is given like something like 1 2 3 2 1. We just had to create 2 arrays or a set with 2 values. You can initialize it to 0 or just insert the first 2 elements like this, and then you have to also have one pair which has this corresponding tower number. So this will be the first configuration of a set, and then subsequently these 3 elements ought to be inserted. So in order to insert this 3, where I should go is I should go to this place, and then I would change this to 4. So this would have and here I need not have initial vector as pair of pair. I just need to have one pair. That's all. So the first value in the pair would be for the element, and the second is for the final position. There is the array tower number. So this would become 1 now, and then it will become 3, and then this 3 should go to the first place, right? Because that's the lower value. So if it is inserted, then it would become the sum would become 4. So this would become something like this, and then this value will be upgraded to 1. So this 2 should be inserted in the first place, in the first location, or in the tower number 2. So it will be 2, and then the sum will be replaced by this. So it will become 4, and then this one should be replaced. Should be placed in the tower number 2. So I will change this, and then I would put the number over here. So after this, it should become something like 5 and 2. So the thing is, we need not maintain a separate pair or separate array to store the initial values. As we are inserting it from the first place itself, the array will always indicate from the starting location to the ending location, and we just have to print this. And this basically works because this is the same logic that we were using there. But over there, what we had was we sorted the array. Like we will insert 2 and 3 in that initially in our first method. But the thing is, it will always be sorted, right? So even if we insert the first two elements, the positions in the in the set initially will be something like this, and this one will also be sorted. So the position at which we should insert this 3 should be the least value always. So we need not sort the array and then insert it in the first place, and then maintain another variable for storing the initial positions. Yeah, this was one vague implementation, but it passed, so it is correct only. So after the contest, I realized that the second method was much easier, and yeah, I was going to other solution, and Kason did with the same method. Yeah, this is the length of his solution. So what he did was he just had one set which contained pairs as its values. So he's inserting 0 in the first place, which is also correct, and it can be done. And the tower number is just the index of that location. And what he is doing now is he will take the vectors elements of the vector as the input, like this. So 1 2 3 1 2, right? So he will take 1 as the input, and then here what he is doing is he will take the pair. He is assigning the first pair to this pair. So the first pair of this set is 0, 0. So this would be 0, 0. And then what he would do is he would just erase the first thing, and then insert the updated value. The updated value will be 1 plus the value which was previously over there, which is 0. So L equals to L plus A. So that will be 1. And then he will place 1, and then the tower position. Tower position is nothing but this D, which is the second value of the pair. And then he is also writing to the console the D plus 1 value, which is the tower number. So that's all. This is the easiest implementation, I guess. As I told in the initial stage, that this was much of an implementation question, but I did not realize that this had one simple implementation. My implementation was much lengthier and confusing, so the second method can be followed. That's it for this video, guys. Hope you like this video, and share it with your friends and subscribe to my channel. Thank you.